Hello all, my name is Janardhan. I am the co-organizer for JavaScript Meetup. Welcome to the fourth session of JS for Newbies. This is an exclusive and initiative from JavaScript Meetup Group. Today we are going to cover the topics of this. There's a keyword, the new keyword, prototype and inheritance. Our speaker today is Patro, Nrusingha Patro. He is a full stack developer with around 10 years of experience. He's currently working at Target. He has made many contributions in the past for this group. He was a speaker for the Angular topic, and he also made several talks for this group. Thank you very much, Patro. Over to you for the session.
Hey, thank you, Janardhan. Hello, guys. So, as Janardhan mentioned, so this is a series which we have started, and we name it like JavaScript for Newbies. So, we are covering all the basic things of JavaScript over this series. So, this is the fourth of that series. We have already done 3 of the series by our other contributors, and I put the links over. So, this repo I can share with you guys. This is I have already shared. I think it's there on our meetup.com, and GitHub link is shared. And in that GitHub link, I have put all my slides, code, and everything. And I put the links also to our past sessions. So you can see I have just created a link so that we can go through those sessions also. And those were pretty good sessions covered by our other JavaScript meetup group contributors. So, and this is the Meetup, our YouTube channel, where you can find all those webinar recordings. So today what I'm going to cover as part of this newbies series, that is this keyword and the new keyword, the prototype and inheritance. So these are the 4 topics which I'm going to talk in next 1 hour and 1.5 hours. So these are the pretty confusing features or the in JavaScript world. Different developer assume it differently. So I'll try to justify these things, what exactly this a new keyword is and how we can use it better. So I'll go to my first topic, that is this and new keyword. So if you guys have any questions, you can post to our chat window, and I might not answer immediately, but yeah, after few times I'll be monitoring that, and I'll try to answer those. Okay, so we'll start with this keyword. So this keyword, if I just have to say in single line, or I have to, or in a layman way, I just say it's an object. So this is nothing but it's an object, and the object which is actually executing the current bit of code, that object this keyword is. Let's say if I put in other word, every function while executing in JavaScript has a reference to its current execution context. That's called this. So JavaScript is all about functions. So whenever this function gets executed, it will have reference to its current that execution context, whatever the context, because every function executes in a context. Without the context, that function will have any meaning. So that context is nothing but it's this. And what I mean by execution context is how that function is called, when it is called, from where it is called. So that's all about the context. So context is, again I'm repeating, how the function is called, from where that function is called. That's nothing but the context. So that context is nothing but a this. So to understand this keyword, only we have to concentrate on how, when, and from where that function is called. It doesn't matter where that function is declared, how it is declared. Those are irrelevant to understand this. So this keyword is all about how that function is called, from where that function is called, and when that function is called. We'll see a quick example so that things may be more clear. So let's say here there is a function bike, which I'm just doing a console log, and I mentioned this start name. Okay. Then we are having this a global variable called name. I've given some name, a bike named Ninja. Then I'm having two objects. Object also having two properties. One is name, other one is bike. And what bike is? Bike is nothing but the global function bike what I have created. That bike I have assigned to here. So bike is nothing but a method to object one, because a property, if it's assigned to a function, becomes a method. So I have a two object. So now we'll take this and we'll execute and we'll try to understand how this keyword is working. So I come to our JSBin editor, and you can see I just put that code. So now we're calling a bike, just a bike here. I'm just highlighting it. And surprisingly, it prints Ninja. How it print Ninja? So by default, this is point to a global context. In case of browser, the global context is nothing but window object. So this points to window object. So that's why when I execute bike and when I say this dot name, you just print this dot name. I just run it. You can see it prints Ninja, Pulsar, and Jigsaw, the three outputs. So the first one, it prints Ninja. I just commented so that, so first it's print Ninja, the bike. That means this dot name is nothing but this global name what I have defined here, var name equal to Ninja. And now when I call the same function object1 dot bike, and this bike is nothing but a property of object1, which is again calling the same function bike, because that's what I have assigned to this property bike. And next time it prints the pulsar, the same function. Oops, sorry, I uncommented, clear it, and I can see it prints Ninja, first one, second one pulsar. Similarly, third one prints the jigsaw. So what does that mean? So here the context of this function bike is this object1. Object1 dot bike, when I call, means the bike function is getting called with the context of object1. Similarly, the bike function is getting called with the context of object2. So that's how this keyword is. That's what I try to explain now. This keyword is nothing but every function while executing has a reference to current context, and that context is this. So whatever we saw now, those are two we saw, the default and implicit binding of this keyword. So there are four different ways this keyword can get bind. And what those four are? One is default binding. What this default binding is global. So if there is no other context for this keyword, it's going to be a global context, and the global in browser is nothing but window. So to make that clear more, if I go here and here, if I just say this dot bike, and you can see that Ninja got print, the first one, this dot bike, which is there. You have declared any function, any variable globally, that's nothing but it's a part of window object, and by default this points to window object in browser. In Node.js it's a global object. Okay, so by default, so that's called default binding of this. And the second one, when I call a function like a method to an object, like I'm saying object1 dot bike, so now the bike will have a context of that object. So now that bike is executing, the bike function is executing with the context of that object, and that's called implicit binding of the schema. So when there is an object property which you're calling as a method, then that object is a context object, becomes this keyword. So that's what is happening in this example. So let's say we'll see one more example to make it more clear the things. Okay, so now what I did here, so I created object one, and object one there is a property called name, and the name of that value of that property is pulsar, and then there is a property called bike, and which is nothing but a function, means bike is a method to the object. Cool. And now I have one more object, that's object two. The property name is name, jigsaw, other bike, and now it is also having a method called bike, and that method, that property I have assigned to object one dot bike. So basically this bike function. Okay, and I have a global variable called name, I have a global variable called bike, and that global variable bike is nothing but again object one dot bike. Okay, so now you can see when I call just a bike, means I'm calling that bike method at a global label, but this bike is actually assigned with object one dot bike, but still this bike will print my global context, that's ninja. So again, that's why it's also we have to concentrate on from where that function is called. So the spike has been called from the global context. That function is declared, that has no significance understanding with this keyword. So that's why when I call bike, although this function gets executed, which is part of object one, but the context is again the global. Okay, and next when I print object one dot bike, then it prints pulsar. Okay, that's pretty clear. I don't have to explain anything here because yeah, bike is a method of object one and name is a property of object one. When I say object one dot bike, so this keyword which is there here, console.log this dot name, obviously this will be nothing but the context of object one. It prints pulsar. That's cool. Now we'll see the last one, that's object 2.bike, and again object 2.bike is nothing but object 1.bike, but when I call object 2.bike, again this bike function will get executed with the context of object 2 because that's the implicit binding, and it will print jigsaw. So what we understood from here, so to understand this keyword, it's only matter how it has been called, from where it has been called. It doesn't matter where that function has been declared, because if you see here in this example, this function is declared inside object 1. But if I call this object 2.bike, this one, and I have assigned that function to my bike, sorry, the object 2's bike, and when call object 2.bike, this is basically I'm executing the bike function with object 2 context, and the name of object, the name property, the value of name property of object 2 is jigsaw. That's why when I execute object 2.bike, jigsaw got printed. So that's called implicit binding. So what we learn, when we learn default binding, which is a global, and then we learn the implicit binding. So we saw how this is nothing but it's a kind of a dynamic in nature, right? How that function is called, and when that function is executing, on which context that function is executing, that this keyword depends entirely on that. Okay, so I'll just pause a moment if I'll see if we have any questions. Yeah. Okay, looks like okay, there is only one question. Will we cover ES6 classes today? So no, I'm not going to cover ES6 class today because I thought it will be too much to cover this key, inheritance and prototype, and then ES6 classes. So if you require, we'll have one exclusive session for ES6 stuffs where we'll cover that. Okay, apart from that, that's all. Okay, I'll move back to slide. Okay, then okay, so one more example to make it clear, the implicit binding and the default binding. We'll try to see that. Okay, in this example, I'm having a function called bike, and inside that, I'm having a variable called name, with the name is pulsar, and I'm having a function called Baz. Okay, this is pretty bad name. Let's see, change this function to vehicle. Okay, makes more sense. Yeah. So I'm inside that I'm having a function called vehicle, and the vehicle is nothing but it just prints the name, this dot name, and I have a global label. I have a var name equal to ninja. Okay, cool. So let's say now, so it's pretty clear. I have a global variable name. I have a global variable function that's vehicle, which just prints this dot name. This again will be a context of uh, that function vehicle when it's executing, and I'm having a bike, and I have a local variable of that bike function, which is name equal to pulsar, and inside bike I call this function vehicle. Okay, cool. So when I run this program, it's actually print ninja, the global name variable, not the local name variable. So you might be thinking, okay, vehicle has been called from inside bike function. So when vehicle prints this dot name, ideally, okay, so it has to take the context of bike. No, that's wrong. So when I call the bike, I called it from a global execution context, and when I say this dot name, so it looks for a global name variable, and global name variable is ninja. That's why it's print ninja. So this local variable doesn't come into picture. That's why the pulsar doesn't get printed. So that's, so here actually the global, the default binding to this keyword applied. That's why we got ninja printed over here. So that's what, again, I'm repeating every time the same. It always matter from where, when, and how your function is get called. It doesn't matter where it has been declared, or exactly from yeah, from where it has been declared. Okay, so we'll move back to our slide. Okay, so now we learned default and implicit binding of this keyword, and we are now obviously a little bit we understood what this keyword is. This is nothing but it's a plain object. That's why you can have property to that object, because if you see this dot name, it's nothing but name is a property to the object this. But when I say object this, what is that object? That object is nothing but it just a reference to the current execution context. That's nothing but an object. So when I call this object 2.bike or object 1.bike, so it happens like this equal to object 1. That's what literally happened when I called object 1.bike. So when bike is getting executed at the line number just before console log this dot name, what will be happening? This equal to object 1. So that's why this is getting everything what is there inside object 1. And then when I say this dot name, which is nothing but object 1 dot name. Good. And then we'll learn explicit and fixed binding of this keyword. So what is explicit binding? So explicit binding is if we call a function with call and apply method, which is available on our function, call and apply method, both of these methods take as the first parameter as the execution context. So you can call any function with call and apply method, and that call and apply method takes its first argument or the first parameter as the execution context, and that is nothing but this binding. So you can see this small example over here. I'm having a function bike whose job is just to print console.log. I mean, just to print the name of the bike. That's nothing but this dot name. I'm printing it over here. And then I'm having a global variable called name, whose value is ninja. Then I'm having an object whose property is also a name, whose value is pulsar. And now I'm calling bike function directly. and next time I'm calling bike dot call, and I'm passing that object as a context for that execution. So this is called the explicit binding. We'll see that here. Now you can see, so when I call bike, obviously it's understood why Ninja will get print over here, because by default this dot name is nothing but the global window dot name. And but when you call bike the function dot call and pass this object as a context, so now the execution context of this function bike got changed, and now the context is object obj, what the object I've created. So now that is the execution context. So now this will be this keyword will be equal to obj. So that's why when I say this dot name, now when my bike dot call get executed, it's actually obj dot name. And what is obj dot name? That's a pulsar. So that's why when I call bike dot call and pass the context as a obj, then my bike function gets executed with the execution context of obj, and then this dot name turns out to be a obj dot name. And in the first scenario, this dot name turned out to be a window dot name. So window is nothing but a global variable in browser, and whenever you create any globals, uh, whenever you create any global variable in JavaScript, it's part of window object. But that's only true if it's in strict mode. I forgot to mention that. So if I say here use strict, when I say use strict, and when I run this, and in this case, I'll just comment this line out. So now it doesn't allow, because in this case, this keyword is nothing but the undefined. You can see now the undefined got printed. So if you are running your program or your function is saying I am in strict mode, then this by default, this keyword points to undefined, not the global variable. So that's why now you can see when I say use strict, this got printed as undefined, but when I remove use strict, now it prints that whole object, this object, which is pretty big. That's entire window object got printed. You can see here. This is a big window object, because now this has point to window. You can see here object window. So now, so I can access this dot name now. Okay, so implicit binding is when you are forcing or when you are supplying a context to the function by using call and apply method. Okay, so one thing is there in explicit binding, we call it fixed binding or hard binding. That's another flavor of explicit binding. And what happens in that case, you don't, so you write a program in such a way every time your context will be same. So your context is now predictable, because in previous scenarios, how your function is get called, and then only we determine, okay, that's what my this keyword will be. But in your hard binding or the fixed binding, what you can do, you can force this object to same always, no matter from where it get called. So that's called a fixed binding. So this is nothing but one more flavor of our explicit binding. So we'll see that. So here again similar, I am having a function called bike who's just printing the name of the bike using this dot name. I'm having two objects, object one, object two. The both are having a name property whose values are pulsar and jigsaw. And then I'm having an original function variable, which is nothing but I'm assigning this bike function, what I've created over here. So original function equal to bike. So I'm just keeping the original bike function. So this is basically a, I can say it original bike function. And then I'm overriding the bike function, and you can see inside that I'm calling original bike function dot call obj1. Okay, that's all. So every time I'm calling this original bike function with object one. So now in last line I'm calling bike dot call obj2, or I'm just calling bike. So you can see the first one, ideally when I call from a global label, it looks for the global, that's window.name. So it's always print the window.name. So I can have one more variable, just a name also. And I can say it. So original, I can name it sports, super sports. Okay, so this is my global this dot name, and this is my obj1 dot name, and this third one is my obj2 dot name. So when I call just a bike function, so what ideally should happen, I will expect super sports to be got printed because it's getting called from a global context, and in the global this dot name is nothing but the global window dot name. But what happens? It prints pulsar. That's nothing but obj1 dot name. Second time when I call bike dot call and I pass a context object to, that's nothing but explicit binding I'm doing. I'm telling execute the function bike with a context of object to, and here the object to name is jigsaw, but again the pulsar is getting printed. Why? Because in this line when I'm saying original bike function dot call and I'm passing object one. So what happened in between? I'm hijacked the bike function and I have override it. And every time I'm passing the same context, that's nothing but the object one. So same execution context object one. So this is called hard binding and a fixed binding. So you can hijack this keyword and you can every time force it to run in this execution context. I mean, sorry, this execution context is a fixed execution context. So at that time, this keyword will, in this example, that this keyword is always point to obj1. So no matter from where you call it, whatever the context you pass, it's every time going to print the pulsar, which is nothing but obj1 dot name. So this is called a hard binding. So now we learn different types of binding now. So first we learned default binding, then the implicit binding, and now the explicit binding, and one more flavor of explicit binding is a fixed binding. So in JavaScript, there is the method also available. That method name is bind, which helps us to achieve this explicit binding, what we learned. So that method, you can see in this example, I'm having a variable called, so I'll just take it, run it, and you'll see. Okay, so in this example, I'm having a bike function. So basically a bike variable which is assigned to a function which will behave as a function only. So a bike function which takes two arguments. One is maker and engine of the bike. And I'm just console logging, printing it everything. So name is nothing but this dot name. So I'm printing the current execution context dot name. Maker is maker, engine is engine, whatever I'm receiving in the function as a parameter. I'm having a variable obj that's nothing but the name is ninja. So obj dot name is ninja, the bike name, and then I'm overriding that same bike function with bike dot bind, and this is what I was saying available to all the functions. So in JavaScript, this bind is a predefined method which you can call, and you can pass the context of execution to that bind method. So I'm passing the execution context, that's obj, my execution context, and the second parameter I'm just passing as a Kawasaki to this function, and then finally I'm calling the bike method. So now you can see how it works. So I pass this here, the engine, the type of engine, that's 1000cc. So when I call this function, so it will come, it will call bike.bind. Obj is nothing but this context, obj, uh, so this obj will be a context of execution for the bike function now. So it will come to this part, and that's how this dot name will be turn out to be a obj dot name. And that's how when I run this, I will get print name is Ninja, maker is Kawasaki, and engineer is 1000cc. So that's how this bind works. So bind takes first parameter as a execution context, and rest is the argument to that function. Whatever the parameters that function accepts, that you can pass as an argument to the bind method. So this bind method is there. You can do that. So apart from call and apply, which helps to do explicit binding, you can do explicit binding with bind method as well. Okay, so with this, we'll just move. If do we have any questions to answer, I'll answer those, and then I'll come back again. Okay, could you please explain the currying concept as well whenever you feel it should be brought up in this video? No, so I think currying has been explained in our session 3, the previous session. So I'm not going to explain currying today. So you can refer to the session 3 of JS Newbies. Okay, so we'll be going back to our slide. Okay, so now we'll come to the new keyword. So I told there are 4 ways you can bind the this keyword. I mean, there are 4 different ways are there when the this binding happens. One we learn default, one we learn implicit, explicit. Hard binding is just another flavor of explicit binding. And finally, one more binding happened to this keyword. That's for that there is one more keyword is there, that's called new. Okay, so now first we'll understand new keyword. What happens when we use a new keyword in JavaScript? The new keyword in front of any function, you can put new keyword in front of any function in JavaScript. When that function call turns to be a constructor call. So there is no restriction. You can only put new in front of that function, or function has to be like that, nothing. You can put new keyword in front of any function, and that function call turns into a constructor call. Obviously that function will do whatever it has to do, but apart from that, there are 4 different things happen when it turns to a constructor call. And those 4 things are: first, it creates a brand new empty object gets created. So whenever you put a new in front of any function, these 4 things happens. It creates a brand new empty object. That new empty object get linked to a different object. Okay, so here I'll take a pause. This different object, I'll talk about this different object in my next slide when I'll explain the prototype. Hold on that, but yeah. So new empty object get linked to a different object. We'll see that what that different object is. Then the third thing happens, this new object gets bound as this keyword for the purpose of that function call. So what the third thing happens, that new object, whatever gets created, that's actually turns out to be this keyword. You can say like that. So that new object, what gets created, that's turned out with this keyword for the purpose of that function call. And if that function doesn't return anything, it implicitly returns this, basically the this keyword. So simple, a brand new empty object got created, a new object get links to some other object, then that new object actually turns out to be this object, and then if the function doesn't return anything, it will return this. Simple. So a simplest use of new keyword is this example. So I'll just put it. Well, so we might have seen this kind of coding from long whenever we are programming in new, but sometimes we don't try to understand what exactly happens behind the scene when we use new keyword. We can just say, okay, in a other programming language, like, okay, it's create an object, it's just create an instance. So I'm not going to into those terminology. So what happens, we just saw that creates a brand new object, gets links to other object, that new object turns out to be this object, and then finally we return this. Okay, so in this example, what I'm doing, I'm having a byte function where I'm having a variable called name. That variable name, value of that variable name is ninja. I'm having one more variable, but that variable is actually part of this dot maker. So it's part of this object, and whose name is Kawasaki. And then I'm just printing console.log this dot name, and then the maker. So you can see we have name available, but I'm printing this dot name. We have this dot maker available, but I'm printing maker. Okay, and we have a one global name and maker also, which is having two different values again, the pulsar and the charge. And now I did this obj equal to new bike. So even I can say, I missed a where obj equal to new bike. And when I run this, what's going to print? Undefined and Bajaj got printed. So this dot name has come as undefined. It doesn't print Ninja. And even the maker, although I have a local maker available inside bike function, but the Kawasaki doesn't get printed. It prints a Bajaj, which is nothing but a global maker variable. How this happens? So that's why we have to understand this. Here, the this and the normal lexical scopes both work in a different way. So both are not same. In the lexical scope scenario, we look for local maker variables. If that's not available, we go for a global. But here, actually, this, if you say this dot maker, that's actually a different word. It's not a local variable to bike. It's a particular execution context variable. That's nothing but a this, and that maker is part of that object, not your local variable. But here, the name is your local variable, but we are trying to print the name of that particular execution context, not the local variable. So this example, I just put it to make things clear, like the local variable name and this dot name are entirely different thing. Local variable maker or this dot maker is entirely a different thing, because when you say this, that's about the execution context, not about your local variable. Okay, so that's what happened. So when I do this, so now let's say if I try to print obj, what happens? You can see it's got printed. So it's an object and it is having a property that's nothing but Kawasaki. So by which we might have understand, when I call new, empty brand new object get created. Okay, second part we'll leave it. It links to something, some other object. Third, that object turns out to be this, and if your function is not returning anything, it will return that this. So that's what has happened. So when I call it this dot maker, so it created a object. That object is nothing but a this, and on that object we created a property called maker, and the value of that property is Kawasaki, right? And if nothing this function is returning, I return this. So when I return this, that this gets assigned to obj, and when I print that obj, now we can see obj is having a property called maker whose value is Kawasaki. This is, so that's what has happened when I use a new keyword. And when I use a new keyword, what I do, I turn that function to be a constructor call. That's why we call it, right? So now when I say this, now this bike will turn out to be a constructor call. We'll see in details what happens when I talk about prototype chains. But for now, this is okay. For now, this is one more way of this keyword binding. That's what we are talking, right? So here also the this keyword binding happens when I call that function with a new keyword. There also I'm passing the context of execution, and that context of execution again has a higher precedence. So because there is a precedence of binding of this keyword, and the precedence is first it checks whether the function is called with a new keyword or not. So if you're calling with a new keyword, then that this gets bind to that new keyword, and that will have a higher precedence. And second, it checks whether the function is called with call or apply method. That's called explicit binding. That's a second level of precedence. Third, the implicit binding, and the fourth one is default. So if it doesn't happen, so if it doesn't happen anything else, then it fall back to a default this binding. So it's a window object in case of no strict mode. In strict mode, it's undefined. Okay, so you might be thinking this hard binding or fixed binding. So it's like another flavor of explicit binding. So it will come in between our new keyword and explicit binding. It's like 1.5 precedence. You can say that. Okay, so these are the different ways how our this keyword binding happens, and these are the easy things what happens when I call a function with new keyword. These four things happen. So we learn about this keyword. Hopefully, people might have understood more now how this keyword works, how new keyword works behind the scene. And now we'll go and understand what is prototype. And before that, we'll see if we have any questions or not. Okay, so there is something like this dot state equal to this dot set state this. Okay, I'll try to answer this later, Sohel. We'll move to prototype. I don't see any other question here. Okay, so we'll go to prototype. Okay, so we understood this and new keyword and the binding everything. So now we'll try to understand the prototype, which is again complex in JavaScript. Every developer have their own meaning of how this prototype works. So I'll try to put what exactly the JavaScript does in case of prototype, and we'll see how it helps. Okay, so what is a prototype? So it's pretty tough question to answer. So what I'll try to explain, like a prototype is nothing but again an object, so which exists on every function. So this prototype is an object which exists on every function in JavaScript by default, and it's just an empty object, nothing. So prototype is an object which exists on every function, and it's just a plain empty object. And your object doesn't have a prototype property. You clear? A function is having a prototype property, but an object doesn't have prototype property. It has something similar which we call underscore underscore proto. Okay, I missed the underscore over here, so it has to be underscore underscore proto underscore underscore. That's what the property name is, which object is having, but the function is having a property called prototype, small dot small p prototype. And this underscore underscore proto underscore underscore, actually it's pretty long to explain. That's why the other name of that is dunder proto. So we call it as a dunder proto, which is underscore underscore proto underscore underscore. Okay, so what we learn again, it's pretty simple. Prototype is nothing but it's an object that exists on every function. It's a blank, empty object. That's all. So when I try to explain, let's say we'll execute this small code and we'll see what happens. Okay, what this small code snippet says, I'm having a function called bike func, which is a function, a blank function, nothing. And then I'm trying to print bike function dot prototype. That's all. Then I'm having a object uh, that's bike, whose property is name, and having the value of that is ninja. And I'm trying to print bike dot underscore underscore proto underscore underscore. And when I run this, you can see both get printed with a blank object. That's all. Okay, so that means you create any function, your prototype property will be available. You create any object, this dunder proto will be available. So that's what the intention of this small code snippet. So that's what your prototype is for a function or for a object. Now we'll go deeper and try to understand more about this. So every single object in JavaScript, it's built by a construction function, be it directly or indirectly. But every time you see an object, it created behind the scene, it built by a construction function, whether you create it explicitly or behind the scene it happened implicitly, but it happens through a constructor function. When we call a function with new keyword, it creates a brand new object that we know from our previous session. Sorry, the previous slide. And each time a constructor is called, a new object is created. That's what I say, be it calling directly or indirectly the constructor. And a constructor makes an object linked to its own prototype. You remember in the previous topic of new, I was saying when you call a function with new keyword, it every time creates a new object, blank object, and that links to some other object. And that some other object is nothing but the prototype. So when you call a function with new keyword, a new brand new object get created and that links to the same function's prototype property. So that's what has happened. So that linkage had happened when I say it links to. And we'll see that detail, what are the benefits we get and how the structure looks like when that linkage happens. Okay, so three things we'll understand the entire prototype. So there are three different things actually available related to prototype. One is dot small p prototype that's available in every function. The other is underscore underscore proto underscore underscore, which is standard proto. That's available to every object. And there is one more things available, what we call this square bracket, and inside that capital P prototype. So I don't know why they have given this confusing names, but this is pretty internal to JavaScript. This is not a enumerable property, or it's not a public a property available, but it's an internal linkage. That's what I mentioned over here. That square bracket, double square bracket, and inside that capital P prototype. Okay, so we'll try to understand. So what these three things are there and where this comes. Okay, so it's a simple function I try to write. So if you see here, what I have highlighted now, I'm having a function car. Okay, I've given a capital C over there. That's just for uh, standard purpose, because you can have a small c or capital C. The function name, it doesn't matter. If you call with a new, it behaves as a constructor. But just to differentiate between a normal function and a constructor function, by visually we just make it caps. That's all. There is no other significance. So function c car, capital car, and it takes a parameter, a name, and I'm just saying this dot name equal to the name what I receive. Okay, cool. Then I'm saying car dot prototype. So I call every function will have a prototype object, right? So on that object, you can create a properties. So car.prototype is a blank object what was already available. So on that, we just created a method called start. And that method or that function, what it does, it just return a string. And that string is saying engine of whatever the car name it's received, this dot name starting. That's what the message it returns. Then what I'm doing, I'm creating two objects, that's C1 and C2, basically the car1 and car2 from my new car function. So as I called it, whenever we put a new keyword in front of any function, it changed that function to a constructor function. So that's what happening. So now my car is behaving as a constructor, and in that I'm passing the values. So that I'll have at the end of this two line of execution, I'll have C1 dot name and C2 dot name, and the values will be Santa Fe and Fiesta. And then on the C2 object, I'm creating speak. So this is a special car which can speak. So it will say C2 dot speak, and it will say console dot log, and it will say hello, and then it will say engine of the car name starting. So that's what is going to happen. So to understand this function pretty more, I have tried to put a diagram. So I don't know how we can put, so I just put it on a plain paper and took a snapshot and pasted it over here, which I felt it will consume me lesser time. So now if you try to understand, so what this diagram relates, this diagram relates to the same program which we are seeing over here. So I try to uh, put that small program in a diagrammatic way so that we can understand what's happening behind the scene when this function gets executed. Okay, so first, okay, so before that, you see there is a right hand side, I put a dotted line. So I'm talking about the right side. So this is default happens in JavaScript behind the scene. So there is a function called object itself. So you know in a JavaScript there is a function name itself is an object. So here the circle represents the object, and the square represents the circle represents the function, and the square represents the objects. So there is a function available. The name of that function is object. That's what you see in the right side circle, and I have written is an object. Then there is a dot prototype. So every function is having a dot prototype property. So that's what that prototype property is there, which actually links to an object. Again, I told dot prototype will be a object, which can be a blank when you create it, but in this case, that object is having a lot of methods, right? So you might have seen few methods like toString, type of. So there are few methods which are comes inbuilt with a function, and that's how it comes. So these actually available in dot prototype of that function object. So we can see that as well. If you go to this, this is nothing but a JavaScript MDN website. And if you go to the object, you can see there are a lot of methods available in object. So you can see object dot prototype, toString, toSource, value of, local string. So these are nothing but these methods are available on prototype property of object. That's what I mentioned here. So this happens behind the scene because this is inbuilt in JavaScript. And now we'll come to our code. So first line, we have created a function, right? The car function. So this circle at the left side, car, that's my car function. And when I create that car function, every function is having dot prototype property. So the dot prototype property is nothing but it points to an object, which is my square. And that object is having a start method, right? That's what we created here. You can see this car.prototype.start, and we have assigned it to a function. So that's what get created over here, and that's how the linkages happen. And from the constructor, sorry, from the prototype object, there is one more link is there. That link is called dot constructor. So there are two links is there between a function and the prototype object. One is that prototype link, and the other is dot constructor link. Okay. That's pretty clear. Now what happens when I execute this var c1 equal to new car? Means I call the function car keyword, then what happens? We know, right? Four things happens when we call a function with new keyword. It creates a brand new object, okay? That's get created at my left bottom corner. That's I have named this c1. So first a blank new object get created, okay, done. Then that object get links to the prototype property of that function. So C car.prototype is nothing but this object where I mentioned start. So that link is created. You can see there is a link from my C1 to object where start is there. Okay. What happens? The third thing. Third thing happened. That new object is actually turns out to be this object. Okay. So when it turns out to be this object, then in my car there is a line called this dot name, right? This dot name. So this dot name is now c1 will have a property called name. Okay, that's how the name comes to that object which gets created. And finally, when that function doesn't return anything, it returns this keyword itself. So it returns this keyword. That's how it get assigned to c1, and that's how I name this object as c1. Pretty clear, diagram. So I can explain that again with a c2 how it happens. C2 again same. When I say var c2 equal to new car, what happens? A brand new get object get created. Okay, I did that. I created a square bracket. Now it get links to a prototype of that function or the prototype of constructor. Okay, that's happened. It get linked, arrow we have created. Third thing, what happens? It turns out to be this object, that brand new object, whatever get created. Okay, so now this dot name actually, so now this name property is a part of that this object. So the name property comes over in that object, and finally it returns that this keyword, and which is get assigned to my variable c2, and that's how I named it c2. Okay, and after that, what I'm doing, I have just created a method for my c2 object, c2.speak equal to a function. So now what happens? That speak method is only gets created in C2. That's why in you see in C1 there is no speak method. Only in the C2 the speak method is there because I explicitly created that method in C2 object only. Okay, so apart from this, what all happens? So this linkage, what gets created between this object and the car.prototype, that internally the name of that linkage is double square bracket capital P prototype. That what the linkage name is. So that's why whenever I mention that square bracket P, that's basically a capital P prototype. Okay, one thing I forgot to mention, there is one more linkage gets created from car.prototype to actually object.prototype. So car.prototype, there's a link you can see which goes to object.prototype. And that link is again this capital P prototype with double square bracket. Okay, so this is what happens behind the scene when this function gets executed. To actually, so if I say this, we have to prove also that exactly happens behind the scene. To do that, what we'll go ahead and execute this code, what I have written over here. Command V clear. Okay, so I try to put few of the console log just to and equal operator so that we can understand whatever I told based on that image actually that's true or not. Okay, so we'll go back to image and we've seen that image. It's pretty clear. Okay, one thing I missed to tell, that is, so in this I told I'll be talking about underscore proto underscore also, where that comes into picture, because that's I'm not seeing anywhere. Okay, so we'll talk about that. Okay, so before that, first I'll say console log. If you see my first console log, all this I'll comment it out. You can see c1 dot constructor equal to car. Is that correct? We'll see in our image. C1, where is C1? Okay, C1 doesn't have a constructor. C1 doesn't have a constructor property. Okay, so if it doesn't have a constructor property, it will delegate to its chain. It will delegate through prototype chain to the upper level. So that's why it delegated. So if it delegates to the upper level object where the start is there, does that is having a constructor property? Yes, it is having the constructor property, right? So that's how it will get a link. So when I say c1 dot constructor, it doesn't have a constructor, so that's why it went to one level up. So and there it finds whether that object is having a constructor property or not. Yes, that object is having a constructor property, which is nothing but a car. So that's why when I print this line, it says true. Okay, and before that, when I'm running this c2.speak and how it's working, c2 dot, so we'll understand how c2.speak is working. So it prints hello engine of Fiesta starting. So it print exactly what we wanted. How it prints, okay, so c2 is having its own method speak. Okay, so there is no problem of going one level up. So it finds it when it prints hello this dot start. So what the context of this over here, the execution context, it's implicit binding c2. So c2 is a context of this over here. So this is basically happens c2 dot start. But does c2 is having start? So we'll go back to our diagram. No, c2 doesn't have a start. Okay, so we have a link. So we'll go, it delegates to it upper object. Does that upper object is having start? Yes, it is having a start method. So that's how the c2 dot starts work. So now c2 dot start happen, and when c2 dot start happen, I return a message saying engine of this dot name. And what is this again over here? Again, the execution context is over here is c2. So c2 dot name is nothing but Fiesta. So that's how it prints hello engine of Fiesta starting. So that's what the benefits of having a prototype chain. Okay, so now we'll see the second one. c1 dot constructor equal to c2 dot constructor. Yes, because c1 doesn't have a constructor, but it delegates to it upper object, and that is having property. Similarly, c2 also doesn't have a constructor property. It goes one level up and try to find. When I print, you can say it's print true. Okay, so c1 dot constructor equal to c2 dot constructor. Cool. Okay, third one. c1 dot underscore proto equal to car dot prototype. Okay, so c1 is having underscore proto? No, it's not having. We'll go back to our diagram. Does c1 is having underscore proto underscore? No, it doesn't have. So it goes to one level up. Does its upper layer object is having underscore proto underscore? No, it doesn't have. So that's how we have a links to the right side. So it goes to the right side, and there is a property available in object.prototype. There is a property called underscore proto underscore, and that prototype is nothing but it actually a get method. So it actually returns this linkage only, which is there between c1 and car.prototype. So it just returns that internal linkage. That's what I was saying. So it just returns that double square bracket capital P prototype. So it returns that. So this double square bracket capital P prototype is nothing but a underscore proto underscore. So that just the internal name is like that. So that's how the prototype chain works. So that's how when I execute this third console, that's c1 dot underscore proto underscore equal to car dot prototype. Yes, it is, because it returns that internal linkage only. So you can see now it returns true. So this now it's pretty clear. Similar way, the c1 dot underscore proto equal to c2 dot underscore proto. That's actually true. Okay, so that's how it has happened. So there is one more method also which returns that internal linkage between the two objects. that object is c1 and car.prototype. So there is an internal linkage is there, right, which is nothing but a double square bracket capital P prototype. So that link we get from a method called get prototype of. So object dot get prototype of, that also returns that link only. So when I print this guy, it's actually returns again a true. So c1 dot underscore underscore proto equal to nothing but object dot get prototype of c1. And these are the method which is already available. We might not have looked into, but if you go to the MDN documentation, you can see there is a property called, you can see here the property object dot prototype dot underscore underscore proto, and you can see there is a internal linkage which is say double square bracket capital P prototype. So these are all already there. Okay, so similarly it is having a property is prototype of, this you can see. So that's how it happens. So get prototype of nothing but it just returns the same link what the c1 dot underscore underscore proto underscore underscore has returned. So similar way, there is one more way how we can get this internal linkages. That's a bit ugly way to get it, but yeah. So let's say this last line of console log, which I am saying c2 dot underscore underscore proto equal to c2 dot constructor dot prototype. Does it make sense? c2 dot constructor dot prototype. It's again written true. So how it is? So c2 doesn't have a constructor. It goes one label up. That on up, one level up object is having constructor. Okay, so c2 dot constructor again coming back dot prototype. c2 dot constructor again coming back dot prototype is nothing but the same link what uh, is there, that's capital P prototype. So that's how all this prototype chain works in JavaScript. So that's how this program works, and that's how our that's what the prototype is. So prototype, you can't so this all is nothing but a prototype only. So prototype is nothing but a link between a function and an object which is linked with an arbitrary linkage that called small p prototype, right? That's a prototype. And there is one internal linkage, that's double square bracket capital P prototype, which get created when we call a function with new keyword. Pretty simple. So first one is whenever you just create a function, one dot prototype property gets created. The capital P prototype surrounding by double square bracket gets created when you call a function with new keyword. And this underscore underscore proto underscore underscore is nothing but a public property which is available on object dot prototype inbuilt to access that internal linkage, the internal capital P prototype linkage. And then there is one more method also which is available, which actually returns the same thing. That's nothing but object dot get prototype of, and you pass the object name. Okay, so that's about the prototype thing. So we'll see if we have any questions. Okay, good. So it's going fine. Then we'll talk about property shadowing, what the property shadowing is. So property or method shadowing is possible, but best practice is to avoid it. Doesn't do it unless until it's pretty necessary for your business scenario. So in this example, we are trying to do a property shadowing, and how we are trying to do this property shadowing will understand. So you can see we have some a constructor function that's car, and then again we are having a method to car.prototype property, and then we created an object c1 with using a new operator, and then I'm just trying to print console log c1 dot start. So c1 dot start, again we understood that diagram, how the prototype link happens, and that's how c1 will have a start method, because c1 doesn't have a start method, but it goes one level up to the prototype chain, and because of those linkage only it can go up, because without those, because those linkages get created automatically when you use the new keyword, and that's how the link between your object and the constructor happens. Because so out of a function, it doesn't copy everything like in other programming language. It just copies everything whatever there in that class to your object instance. But in JavaScript there is no copy. It just creates a link. So you can, that's how you access it. Okay, so when I say c1 dot start, uh, so what I'm trying to do now, you can see there is already a start method is there in car.prototype property, and I'm creating one more start method in my c1 object itself. So this is like I'm shadowing the car.prototype.start with my c1.start. So this is how the shadowing happens. So the problem is, see, this shadowing is when you call c1.start, it always looks for whether that object c1 is having a start method or not. If it's having a start method, it just calls that. So now in this case there is a no way you can access, or there is a way, but there is no easy way you can access your car.prototype.start. So if you have to access that car.prototype.start, then you have to say explicitly, you can say car.prototype.start, and then you have to pass the context also now. And then that's why you have to call this call method, and then you pass a context this, and here this is nothing but the c1. So now if you run, then so first when I run this line, it just says engine of Fiesta starting, and when I say c1.start, it just added one more hello, and there again I'm calling the original start method. So this example I have just given to show you, if you do a property shadowing, how you can call your uh, constructor method, the original method which you have already shadowed with your local object method. So you can do that by car.prototype.start, and then you have to depend on your call and apply method, and then you have to pass the context of the execution. The explicit binding will come into picture. So here it's basically, yeah, the explicit binding will come into picture to achieve what you want. So that's how you can shadow it, and still you can call your shadowed method or property. And then the object linking. Um, so I'm talking about your object linking, but if you see in my diagram, it's everything is linked. So anything we do, everything is get linked, and that's how we traverse through our prototype chain, and that's how we sometimes we say what is a prototype chain, and this is nothing but a prototype chain, because it just creates a chain to your extreme global inbuilt variables. So you can traverse to the upmost level because of this prototype chain only. Okay, so there is one more method. Want to achieve a parent class and child class kind of scenario, right? Which we call inheritance, which is my next topic. So just before that, I'm just setting it up a small example. So let's say I want to achieve that parent and class scenario, and how we do that, right? So we'll see it here. So it's simple. I have a, let's say vehicle is a parent class, which is just having a name property. Now I'm talking about in more a traditional object oriented style. So vehicle is a parent class because there is nothing in ES5 still the class something. So it's again a function only for JavaScript point of view. But yeah, so I'll just talk how the other programming language talks. So this is my parent class. So parent class is having a property called name. And in this parent class, I added a method called start. So in JavaScript, we do that with vehicle.prototype.start. Cool. Now I created another class called car, and in that car I'm actually calling my vehicle function, and I'm calling with a call method, and I'm passing the context. I'm passing the context for the execution and the argument what that function receive. And now this is a line which is creates a link, the object linking. So I'm saying car.prototype equal to object.create. So object.create again inbuilt method available in JavaScript. And what that create does, it just two things of it just do first two steps of new, what new does. So what are the first two steps of what new does? It creates a brand new object, and it links to the constructor of prototype, and that's what we are doing over here. So car.prototype equal to object.create vehicle.prototype. So that's how now my vehicle.prototype, the car.prototype is linked to vehicle.prototype. So you can assume in this scenario, if I does that, so what will happen? So I think I have another image where I can show that what exactly, but you might have understood one more object will come, and that will get linked to this car.prototype. So one more circle will come, one more square will come, and that square will get linked to this square. That's how the link will happen. And now when I say car.prototype.speak, means I'm adding a method to my car.prototype. That's all. And now I'm creating two new objects, C1, C2. And when I call C1.speak and C2.speak, internally, because of this prototype chain, I still get hold of this name object and everything. So we can see that. So I'll just take this, I'll put it over here. Here, run. You can see it's printing pretty fine. So when I'm calling new car Fiesta, so now C1 is having speak method, and inside the speak method I'm calling this.start, but C1 doesn't have a start method because C1 has been created with new car, and car doesn't have speak method. So how it gives, and because of that links it hold to the, sorry, car is having speak method but it doesn't have a start method. How it gets because I linked this car.prototype equal to object.create vehicle.prototype. So there is a link get created between car.prototype and vehicle.prototype. So it goes to its prototype chain, goes up and get the start method which is there in vehicle.prototype, and it just execute with the C1 context. So when I say C1.start, it goes to here, and here this dot name is nothing but C1 dot name, which is nothing but Fiesta. Second case, similar thing happens with the C2. So this dot start can change it to C1 dot start, and this dot name changes to C1 dot name, and same happens when I call C2 dot speak. So this is how you can create a relationship between two objects, and it behaves like parent and child. And in JavaScript, parent and child, it just creates a link, and we think like it behaves a parent and child, but from a JavaScript point of view, it's just a prototype chain. So it just travels through that chain. It doesn't understand what is parent, what is child. Okay, so summary of this prototype is the constructor. We understood what the constructor is, just a function which gets called with a new keyword in front of it. But dot constructor is the property that what we saw. And double square bracket prototype is a linkage we saw between one object to another object, right? It gets create when we call object.create also, or when we call a function with new keyword. So two ways this double square bracket prototype creates, one with create.object and one with new keyword. And this underscore proto and get prototype, object.get prototype, or constructor.prototype all returns this link only. So this link which I'm talking about, which is there between c.prototype. So there are three ways you can access to that link. One is, because this capital A prototype is not a public property, so to access this, either we can access through underscore proto, or with object.get prototype of, or with dot constructor dot prototype. Cool. Okay, so that's all about a prototype. So I'll take a few more minutes just to cover inheritance. Hopefully we are on time. Okay, so the last topic of today's session is inheritance. Again, inheritance is pretty confusing in JavaScript because this inheritance actually has come from classic object-oriented languages like C++ is Java. So the inheritance, actually the concept come from here. So inheritance literal meaning is copying, right? So if I if I say like my child, like the DNA. So my child will be like my DNA get copied to my child, but we both are different entity, right? So that's how the classical inheritance works. So like from a car sketch which the engineers gives, the manufacturer create a car out of that. So the sketch is a kind of a parent, and a car which has come out is a child. But actually there is a no relation. So this car and the sketch can live independently. If something happens to the actual car, let's say a tire got broken to actual car, nothing happens for this blueprint. It's still the same, right? Because two are two different entities, and that's how the classical inheritance, like the programming languages like Java, C++ works. So whenever you create an instance out of that, or whenever you say I'm a child of this class, so what happens, this child actually copies everything whatever there in a parent to its own instance. And now after that there is a no relation between the parent and child. Only during a creation phase it just copies everything. That's how the classical inheritance work, right? So this is a small diagram I put it to explain it, the non JavaScript inheritance, how it works. Let's say there is a vehicle parent class is there. I can create two object out of that, v1 and v2. You can see the arrows, like arrow is outwards, right? From vehicle the v1 gets created, from vehicle the v2 get created. Once it's done, now vehicle and v1 is two separate entities. There is no exact relationship between them. Similarly, let's say car is a child class of vehicle parent. When I create car out of vehicle, car just copies all the entities of vehicle, and now car is a separate entity. And when I create an object out of C1 and C2, similarly. So all arrows are like towards what has been created. And after that, there is no relation. So that's how the classical inheritance work. So it creates a copy of class when I create an instance or object, and after that class and instance both are separate entity. But what happens in a prototypal inheritance, what we call it in JavaScript, the prototypal inheritance, but actually speaking, JavaScript doesn't have any inheritance. But we can solve the similar thing by our prototype chain, and we try to make it behave like inheritance, because this C++, Java, and these are pretty popular languages compared to JavaScript at one point of time. And they were saying, okay, inheritance is there, a good programming way to solve a few of the problems. So that's how people try to do it in JavaScript also, and we name it as a prototypal inheritance. But if we talk, it's just a delegation pattern or prototype linkage. We'll see that how it happens in a JavaScript way of doing it. So when I say prototypal inheritance, I say vehicle.prototype is a parent, and when I create an object out of that, so look, let's say vehicle is a parent class. So when I create an object out of that, what happens? The link get created. That's what we saw in our previous diagram, right? So the v1 creates a link to vehicle.prototype. When I create a v1 from vehicle constructor with new keyword. Similarly, if I create v2, you can see the arrows are going towards. So after we create also, both are not a separate entity because it's a link. So every time if I try to access any method which is there through this v1, if it's not available in v1, it goes up and it try to find that. And that's how JavaScript works. It's all work through the prototype link. And similarly, if I create a child class called a car, what happens? There is a link gets created between vehicle.prototype and car.prototype. So if anything not available in car.prototype, it goes to vehicle.prototype and try to get access of those properties or the methods. Similar way, car.prototype can have its own objects, C1, C2, and everything. Again, this works in a similar way. So V1 and V2 is linked to vehicle.prototype, because it's been created using new keyword. And similarly with C1, C2 create linked with car.prototype, and car.prototype is linked to vehicle.prototype. So it's all linked. So in JavaScript, when we create object, it doesn't copy the property of constructor. It just creates a link, which is a difference between Java, C++, and JavaScript. Java, C++ it doesn't create a link. It just copies everything and makes its own. Okay, so this is a small example of what I try to explain this prototypal inheritance. What in a JavaScript there is a pattern called behavior delegation pattern. That's actually a similar to prototypal inheritance. Let's say I put this example over here. Okay, so again, so I'll talk in a regular object-oriented way of explaining the inheritance. So vehicle is a parent class over here, which is having a start method, which is in JavaScript, it has to be vehicle.prototype. Similar car is a child class, which actually calling the parent class, and we are creating a link between car.prototype and vehicle.prototype, and that's how we establish the chain, right? This example we have already seen before. Okay, so and this is how we achieve the inheritance in JavaScript. So we just create a link from to one object to another. So if you see, it looks this program looks a bit complex because there are so many dot prototype which might confuse us, because and this is a way we can achieve the inheritance in JavaScript using this linking this prototypes. But without this prototype also we can achieve the similar thing, and that's what I'm going to show you now. So, and let's say first thing what I, so this we know, so if we run this, it works pretty fine. We have already seen this, and it goes through its prototype chain to the parent. So if I talk in traditional classical inheritance way, so when I call c1.speak, so c1.speak, when this dot start happen, c1.start, c1 doesn't have a start method, it goes to its parent. Parent is nothing but vehicle. Vehicle is having a start method, and that's how c1 gets the start method. So when I say c1.start is executing, this dot name changed to c1 dot name because the execution context changed to c1. That's how it works. So we know when we run this new car, what happens behind the scene. It creates a brand new object and then it links, right? So let's say we do the same thing without this. So I'll just comment out this guy, and I'll take this, I'll put it over here. Now what I did, instead of new keyword, what I did the same. I did object.create car.prototype. So what I did, I created an object C1 and I just linked to car.prototype. Cool. Done. So in new object, what it's done, it just first two steps I did. And what happens in the next two steps, that new object what created new keyword, it actually assigned to this keyword, and finally we return this, right? And that's what I am doing in this line of code. Car.call. So I'm calling a car function and I'm passing the context of this C1. So I'm passing this context, and I'm passing this variable which I was passing in case of new, right? And finally, when I run this, it's actually returns me the same result. So I eliminated the new, all the constructor confusion, anything. Now there is no constructor coming into picture, at least for the car. And I achieved the same thing by using my object.create and car.call method. Okay, so we'll further refactor this code. So what my aim is, I can achieve the similar inheritance concept without using prototype, constructor, new keyword, nothing. Just the object and methods I'm going to use it. Okay, so what I'm doing next. So what, okay, so I think this, okay, so what, what I do, I'll just copy this two stuff. So what I'm doing, I'm just removing this function car. Okay, so what I did, I just remove this. I just comment out so that it will be more clear. So I just commented out this car. What I did, I created a variable car, and again I did object.create. So instead of dot prototype, which I'll again comment it out, I just create, instead of dot prototype, I just create a simple variable and the same link I created, the same line of code. And then I created an init method, which was actually happening inside my constructor function. And that init function is now actually calling the vehicle.call this. And this init I can call over here. So instead of saying car, dot call, I can let's say car dot init. Cool. And now if I just execute, what says? Oh, sorry, it has to be c1 dot init. Right. So I created c1 is having an init. C1 dot speak. Okay. So I have given you car dot prototype speak, which has to be car dot speak. That's all. So now I just removed this prototype object from in between. So now I created just a normal object. Instead of car dot prototype, I created a car object. Same link I did to vehicle dot prototype, and then I did car dot speak. And instead of that, I did this, and then what gone wrong? Got it. Object.create instead of car.prototype, it has to be car. Everywhere I have to remove prototype. Yeah, it looks same fine. And finally, in interest of time, I'm just copying this guy. You can see, oops. Good. So now you can see I have removed everything, that init method. So now I created a simple object called vehicle, and it is having two methods. One is init, other is start. I created a variable called car. I created a link by using object.create, because object.creates a link, and then car is having a speak method, and there I'm doing this start. And similar way, I'm creating a, instead of new, I'm doing object.create, and then I'm initializing the c1. C2, I'm creating an object out of car, and I'm doing the init, and I'm saying same c1.speak, c2.speak, and when I run it, it returns the same result again. So here you can see I achieved the same inheritance without using dot prototype, without using new keyword, without having a constructor. So this is nothing but a pattern which is called object delegation pattern, behavior delegation pattern. So my point of view is not, it's not about you should not use prototype, but using prototype just make a bit of complexity to your code. But if you understand entire prototype chain pretty good, you can still do that. But I'm saying without prototype, using dot prototype also, you can achieve what we call prototypal inheritance by this what I have done using your, because just you have to link object, because that's what we understand, right? So in JavaScript, when we say inheritance, it's nothing about behind the scene, it just link the objects. So if we understand that core, okay, behind the scene, it actually links the object. So if it's linked the object, why can't I create my object and I can just create a link so that it behaves like the same inheritance? If you see, it's behaves same inheritance because C1 doesn't have a speak method. It's still, sorry, C1 is having speak method, and the speak method inside uses a start method. And C1 doesn't have a start method. So it goes to its parent, and from parent it borrow the start method. Similarly, C1 doesn't have an init method, but it can go to its parent and can execute this init function. And but here there is no parent and child. It's all about how you create the links, the prototype links in JavaScript. And to create that prototype links, there is a method available that's object.create, which is pretty powerful. It can link your two objects. And if you just finally see the diagram, how it will be of this program, what you're seeing over here, it will be like this. So it will be like this. You can see here, we have a vehicle object. Objects are, I have mentioned the square, right? So vehicle is having two methods, init and start, and car is just linked with a vehicle. That's what we have done, right? Car equal to object.create and passing a vehicle object. So this link got created. This link is nothing but again that square bracket p, which you can get from get prototype of or underscore underscore proto. And similarly from car object, I created two new object that's nothing but c1 and c2. So and c1 and c2 again gets linked to my car. And when I say c1 dot init, that's how, because of this chain, it gets init. I can still say c1 dot toString, I'll get it, because there is automatic links get created from each object I called. There is a link which is underscore underscore proto, which is actually goes to object dot prototype. So that's how all the inbuilt methods. So if you see, the entire JavaScript works in that way. That's why when you create a string, and in that string, if you say two lowercase, two uppercase, you get those methods. How you get those methods? Because these prototype chains are behind the scene, making you available those methods just on fly. So that's why when I say c1 dot toString, I'll get it, because I have that prototype chain link, and because of that link, I just get it, all those methods. So this is what the prototype inheritance, what we call in JavaScript, is all about. So this is inheritance. So if, and you can achieve this inheritance without the new, without the constructor, and without the prototype thing. But behind the scene, yeah, it happens. Those things only are there to help you out. Okay, so we'll go back to our question page. Okay, so looks like no questions. So if you guys have anything, you can ask me. That's all what I have for this session. Um, this keyword, the new keyword, the inheritance, and the prototype.
Okay, thank you very much, Patro. Thanks everybody for joining. You can post your questions on Slack. The channel is JS for newbies. Would look forward for your feedback. Thank you very much.
Thank you guys. Bye bye.